2002 National Electrical Code, or NEC, has specific requirements for low-voltage lighting cables. Generally, these cables need to be exposed unless certain conditions are met. These exceptions include when the cables are protected in approved enclosures or raceways, concealed in the framing directly behind the lighting fixture or outlet itself, or installed in Class 1, Division 2 hazardous locations. An important consideration is the proposed installation, specifically whether it meets code. Concealing low-voltage cable in an attic space without proper protection, such as an approved enclosure or raceway, typically does not meet code. Several acceptable solutions can bring the installation into compliance. Firstly, one can run the cable in an approved enclosure. This involves housing the low-voltage cable within a protective barrier that meets specific safety standards. Secondly, consider installing the low-voltage cable in a flexible or rigid conduit. This conduit must be accessible for future inspection and maintenance, allowing for easy troubleshooting and repairs. Thirdly, installing a remote transformer may be a valid solution. This entails placing the transformer in an accessible location outside of the attic space. Example locations include the exterior of the house or a basement. From this remote location, the low-voltage cable is then run to the attic and subsequently down to the lighting fixtures. Fourthly, concealing the cable directly behind the lighting fixtures is another approach. Install the low-voltage cable in the space directly behind the lighting fixtures or outlets. This ensures the cable is concealed when the fixtures are properly mounted. Additional factors to consider include ensuring the transformer has an accessible disconnect switch for servicing. This allows for safe and convenient power shutoff during maintenance or repairs. Use appropriate low-voltage cables that are rated for the voltage and power requirements of the lighting system. This prevents overheating and potential fire hazards. Always follow all manufacturers' instructions for the proper installation and operation of the low-voltage lighting system. This ensures optimal performance and safety. It's always recommended to consult with a qualified electrician to ensure the installation meets current NEC requirements and is safe for use. Electricians have the knowledge and experience to navigate the complexities of electrical codes and safety regulations. Considering the voltage drop in low-voltage lighting systems is crucial for ensuring optimal performance and longevity of the lighting. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor, such as a wire, due to the resistance of the wire. Excessive voltage drop can lead to dimming of lights, reduced light output, and even damage to the transformer or lighting fixtures. Firstly, longer wire runs increase voltage drop. The longer the distance the electricity has to travel, the greater the resistance encountered, and consequently, the greater the voltage drop. Secondly, smaller wire gauges have higher resistance. The gauge of a wire indicates its thickness, a smaller gauge number signifies a thicker wire. Thicker wires have lower resistance and therefore minimize voltage drop. Thirdly, higher current draw increases voltage drop. The more current that flows through a wire, the greater the voltage drop will be. This is particularly important to consider when using multiple light or high wattage fixtures. To mitigate voltage drop, several strategies can be employed. Firstly, use thicker wire gauges. Upgrading to a thicker wire gauge, such as from 14 gauge to 12 gauge, can significantly reduce resistance and minimize voltage drop, especially over longer distances. Secondly, shorten wire runs. Whenever possible, minimize the length of the wire runs. This can be achieved by strategically placing the transformer closer to the lighting fixtures. Thirdly, use higher voltage systems. Low voltage lighting systems typically operate at 12 volts or 24 volts. A 24-volt system will generally experience less voltage drop than a 12-volt system for the same wattage and distance. Fourthly, consider parallel wiring. For multiple lights, wiring them in parallel instead of series can help distribute the current load and reduce voltage drop. Fifthly, calculate voltage drop. Various online calculators and formulas can help estimate voltage drop based on wire gauge, length, current, and voltage. This allows for informed decisions about wire size and system design. By carefully considering voltage drop and implementing appropriate mitigation strategies, one can ensure that the low-voltage lighting system operates efficiently, reliably, and safely. In addition to the NEC requirements, it's essential to understand the specific requirements for different types of low-voltage cables commonly used in lighting applications. Common low-voltage cables include thermostat wire, speaker wire, landscape lighting wire, and Class 2 power cables. Thermostat wire is typically used for low-voltage control circuits, such as those found in thermostats and HVAC systems. It's generally not suitable for lighting applications due to its thin gauge and low voltage rating. Speaker wire is designed for connecting speakers to audio amplifiers. While it can sometimes be used for low voltage lighting in certain situations, it's essential to ensure it meets the voltage and current requirements of the lighting system. Landscape lighting wire is specifically designed for outdoor low voltage lighting applications. It's typically direct, burial rated, and resistant to moisture, UV radiation, and other environmental factors. Class 2 power cables are commonly used for low voltage lighting systems powered by Class 2 power supplies. These cables are designed to meet specific safety standards and are typically marked as Class 2. When selecting low voltage cables for lighting applications, consider the following factors. Firstly, voltage rating is a critical consideration. Ensure the cable's voltage rating is sufficient for the voltage of the lighting system. Secondly, current carrying capacity is another key factor. The cable must be able to safely handle the current draw of the lighting fixtures. Thirdly, environmental conditions play a vital role. For outdoor installations, use cables that are rated for direct burial and resistant to moisture, UV radiation, and temperature extremes. Fourthly, compliance with safety standards is imperative. Choose cables that meet relevant safety standards such as UL or ETL listings. Improper cable selection can lead to overheating, electrical shock, or fire hazards. Always consult with a qualified electrician or refer to the NEC for specific cable requirements in your application. Understanding the different types of low-voltage cables and their appropriate applications is crucial for ensuring a safe and compliant lighting installation. When installing low-voltage lighting systems, it's crucial to understand the different types of transformers and power supplies available and how to choose the right one for the application. Transformers are used to step down the standard line voltage, typically 120 volts, to a lower voltage such as 12 volts or 24 volts, suitable for low voltage lighting. Power supplies, on the other hand, convert AC voltage to DC voltage, which is required by some low voltage lighting systems, such as LED lighting. Firstly, magnetic transformers are a common type of transformer used in low voltage lighting systems. They are generally robust, reliable, and cost-effective. Secondly, electronic transformers are smaller and lighter than magnetic transformers. They are also more energy efficient, but can be more sensitive to voltage fluctuations. Thirdly, LED drivers are specialized power supplies designed to provide a constant current or constant voltage to LED lighting fixtures. They are essential for ensuring proper LED operation and longevity. When selecting a transformer or power supply, consider the following factors. Firstly, wattage is a critical factor. The transformer or power supply must have sufficient wattage to power all the connected lighting fixtures. Secondly, voltage is another key consideration. Ensure the transformer or power supply outputs the correct voltage for the lighting system. Thirdly, input voltage is something to consider. The transformer or power supply must be compatible with the available line voltage. Fourthly, environmental conditions matter. For outdoor installations, use transformers or power supplies that are rated for outdoor use and resistant to moisture and temperature extremes. Fifthly, safety certifications are very important. Choose transformers or power supplies that meet relevant safety standards such as UL or ETL listings. Additionally, it's important to consider the wiring methods and overcurrent protection for the transformer or power supply. Transformers must be properly wired and grounded according to the NEC. Overcurrent protection, such as a fuse or circuit breaker, is essential to protect the transformer and wiring from overloads and short circuits. Selecting the right transformer or power supply is crucial for the safe and efficient operation of a low-voltage lighting system. Always consult with a qualified electrician or refer to the manufacturer's instructions for specific recommendations. Another important aspect of installing low-voltage lighting systems is understanding grounding and bonding requirements, as these are crucial for electrical safety and preventing electrical shock hazards. Grounding refers to connecting electrical equipment to the earth, providing a low-resistance path for fault currents to flow back to the source. Bonding, on the other hand, involves connecting metallic parts of electrical equipment together to create an electrically conductive path. Firstly, all metallic enclosures of electrical equipment, such as transformers, power supplies, and junction boxes, must be grounded. This provides a safe path for fault currents to flow in case of an insulation failure. Secondly, low-voltage lighting fixtures with metallic parts must also be grounded. This protects against electrical shock if a live wire comes into contact with the fixture's metal housing. Thirdly, grounding conductors must be properly sized according to the NEC. The size of the grounding conductor depends on the size of the circuit conductors. Fourthly, grounding connections must be made securely and reliably. Loose or corroded grounding connections can compromise the effectiveness of the grounding system. Fifthly, bonding is required for all metallic parts that are likely to become energized. This includes metal conduits, metal enclosures, and metal supports. Sixthly, bonding conductors must be sized and installed according to the NEC. The size of the bonding conductor depends on the size of the circuit conductors. Seventhly, bonding connections must be made securely and reliably. Loose or corroded bonding connections can compromise the effectiveness of the bonding system. In addition to these general requirements, there may be specific grounding and bonding requirements for certain types of low-voltage lighting systems, such as those used in swimming pools or spas. It's essential to consult with a qualified electrician or refer to the NEC for specific grounding and bonding requirements in your application. Improper grounding and bonding can create dangerous electrical shock hazards. Always follow the NEC and manufacturer's instructions when installing low-voltage lighting systems. The NEC specifies the use of listed or labeled equipment. This means that electrical equipment, including low-voltage lighting systems, must be evaluated and tested by a recognized testing laboratory such as UL or ETL to ensure it meets safety standards. Firstly, listed equipment has been tested and certified by a recognized testing laboratory to meet specific safety standards. This provides assurance that the equipment is safe to use when installed and operated according to the manufacturer's instructions. Secondly, labeled equipment bears a label or mark from a recognized testing laboratory indicating that it has been tested and certified. The label also provides information about the equipment's ratings, such as voltage, wattage, and environmental conditions. Thirdly, using listed or labeled equipment is a requirement of the NEC. Electrical inspectors will typically look for the listing or labeling mark to verify that the equipment meets safety standards. Fourthly, using unlisted or unlabeled equipment can void warranties and create safety hazards. Unlisted equipment may not have been properly tested and could pose a risk of electrical shock, fire, or other hazards. When selecting low-voltage lighting systems, always look for the listing or labeling mark from a recognized testing laboratory. This ensures that the equipment meets safety standards and is safe to use. In addition to the general requirements for listed or labeled equipment, there may be specific requirements for certain types of low-voltage lighting systems. For example, low-voltage lighting systems used in swimming pools or spas must meet specific requirements for underwater lighting and grounding. It's essential to consult with a qualified electrician or refer to the NEC for specific requirements in your application. The National Electrical Code provides detailed guidelines on wiring methods, which are crucial for ensuring safe and compliant installations. These methods dictate how electrical conductors are installed and protected, minimizing the risk of electrical hazards. Firstly, conductors must be protected from physical damage. This can be achieved by using conduit, raceways, or other approved methods. Secondly, conductors must be properly supported. This prevents the conductors from sagging or becoming damaged. Thirdly, conductors must be insulated. This prevents electrical shock and short circuits. Fourthly, conductors must be sized correctly. The size of the conductor must be appropriate for the amount of current it will carry. Fifthly, conductors must be identified. This makes it easier to trace and troubleshoot circuits. Sixthly, conductors must be terminated properly. This ensures a secure and reliable connection. Seventhly, conductors must be protected from overcurrent. This protects the conductors from overheating and causing a fire. There are a variety of wiring methods available, each with its own advantages and disadvantages. Some of the most common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable. Rigid metal conduit is a heavy-duty wiring method that provides excellent protection from physical damage. Electrical metallic tubing is a lightweight wiring method that is easy to install. Flexible metal conduit is a wiring method that can be bent and flexed, making it ideal for tight spaces. Non-metallic conduit is a wiring method that is resistant to corrosion. Cable is a wiring method that consists of two or more insulated conductors enclosed in a sheath. The best wiring method for a particular application will depend on a number of factors, including the type of environment, the type of electrical equipment, and the local electrical codes. When selecting a wiring method, it is important to consider the following factors: the environment, the type of electrical equipment, and the local electrical codes. It is also important to consult with a qualified electrician to ensure that the wiring method is installed correctly. Overcurrent protection is a critical safety feature that protects electrical circuits from damage caused by excessive current flow. This protection is typically provided by fuses or circuit breakers, which are designed to interrupt the flow of current when it exceeds a predetermined level. Firstly, fuses are one type of overcurrent protection device. A fuse contains a metal filament that melts and breaks the circuit when the current exceeds the fuse's rating. Secondly, circuit breakers are another type of overcurrent protection device. A circuit breaker is a switch that automatically trips and interrupts the circuit when the current exceeds the breaker's rating. Thirdly, overcurrent protection devices must be sized correctly. The size of the overcurrent protection device must be appropriate for the size of the circuit conductors and the load they are serving. Fourthly, overcurrent protection devices must be located in readily accessible locations. This allows for easy inspection and replacement. Fifthly, overcurrent protection devices must be properly maintained. This ensures that they will function properly when needed. Overcurrent protection is an essential safety feature that can protect electrical circuits from damage and prevent fires. It is important to select the correct overcurrent protection device for the application and to install it correctly. The National Electrical Code outlines specific requirements for electrical boxes. These boxes, also known as junction boxes or outlet boxes, are enclosures used to protect electrical connections and provide a safe mounting point for electrical devices. Firstly, electrical boxes must be sized correctly. The size of the box must be large enough to accommodate the number of conductors, devices, and fittings that will be installed in it. Secondly, electrical boxes must be made of approved materials. The materials must be appropriate for the environment in which the box will be installed. Thirdly, electrical boxes must be securely mounted. This prevents the box from moving or becoming damaged. Fourthly, electrical boxes must be accessible. This allows for easy inspection and maintenance. Fifthly, electrical boxes must be properly grounded. This provides a safe path for fault currents to flow. There are a variety of different types of electrical boxes available, each with its own advantages and disadvantages. Some of the most common types of electrical boxes include metal boxes, non-metallic boxes, and surface mount boxes. Metal boxes are strong and durable, but they can be susceptible to corrosion. Non-metallic boxes are resistant to corrosion, but they are not as strong as metal boxes. Surface mount boxes are easy to install, but they are not as aesthetically pleasing as recessed boxes. The best type of electrical box for a particular application will depend on a number of factors, including the type of environment, the type of electrical equipment, and the local electrical codes. When selecting an electrical box, it is important to consider the following factors: the environment, the type of electrical equipment, and the local electrical codes. It is also important to consult with a qualified electrician to ensure that the electrical box is installed correctly.